So I've got a couple of things this week which I was going to take us through. One of them was involving ways of building curved surface objects and having those propagate across multiple parts. And the other was just something I've been working on this week, where I reuse a lot of the knowledge that we've covered in previous sessions about using design tables and equations to using those to kind of drive designs to make them more flexible. So before we get into trying to work out how to get back to the Zoom controls, because now I have, there we go. I'm just going to stop screen sharing for a second just to make my camera full screen. So the first thing that I wanted to kind of go through, I had a design challenge set to me by my wife recently. She'd got these double-sided razor blades that she was using to score the dough when she's making bread. And she wants, as the bread rises, she wants the kind of top of the loaf to kind of split so that it doesn't kind of like expand the wrong way. And so she uses these razor blades. And she said, problem is that they're kind of really fiddly, and she's worried she was going to cut her fingers. So could I make a razor blade holder? And so that's what I'm going to go through first tonight, because the design of this little 3D printed case that clips around the razor blade actually threw up quite a few interesting design challenges. So that's kind of what we're going to look at. Let me put the screen share back on.
A quick question.
Yes, go ahead.
If I were completely ignorant as to CAD and I was trying to, and I'd submitted a request for the Solidworks software, who could I poke to actually get that?
Me is the answer to that. If you've put a request in, I don't get notifications for them, so I do look every few days. And I do see we've had a flurry of people who have put them in just after I last checked. So I apologize for not having dealt with those. I'll get those processed after this session.
Thank you.
And you should get an email from me with details of how to install the software.
Okay. And just to confirm on that, is and I'm sorry for pushing on this, but is Jonathan McBride on that list?
Yes, he is.
Okay, cool. Thank you very much.
Yeah, so his requests come through. Yeah.
He is I.
Yeah. So yeah, you're on there. Yeah, I apologize. I've not looked at it for a few days, and the last time I checked, I was up to date with checking everybody off. But I see I've got 4 on there now, so I will get onto that after the session.
I'm in a similar situation too. So, thank you.
Yeah,
Thank you.
yeah, I see your details on there as well, Abhishek.
Thank you.
Okay, so designing this razor blade holder, I started off with the problem of making the actual shape to hold the razor blade in place at an angle. So I started with a simple rectangle and then kind of cut out the shape for the razor blades to clip into and the mounting parts for it. And I did a few 3D prints of this to kind of iterate on that to get the dimensions right, because often what you 3D print comes out very slightly different in size to what you design in CAD, because of the way the plastic kind of oozes out of the nozzle. Sometimes holes are slightly smaller than you design them, and the kind of exterior perimeters are sometimes slightly bigger. And so I did a few iterations of that just with a simple block to get it right. And then I started looking at how to kind of give it a profile that would enable my kind of, when you were using it, to hold the razor blade so that you could put your finger to put downward pressure. So that's kind of pressure down in kind of this direction towards the top of the razor blade. And what we ended up with was this shape. So I thought I'd start with kind of how to generate this kind of curved shape, and then we'll look at how I applied it to the existing model. So if I go to the part where I actually drew that, this is the sketch that cuts that that shape out of the block, and the sketch is using a spline line. So I'm going to start a new part and draw one from scratch. And we'll actually design this how would be most sense in hindsight. My part actually evolved over several iterations and ended up being drawn in a slightly complex way. So we'll start with a boss extrude, which I'll put on the front plane. And I now need to draw the shape that I want. And when I select the spline, what I can then do is click, and you can see that a spline is a curve that joins between points in a smooth manner. And I double click to finish. And because I need a closed shape, I'll just join up those with a straight line. And then I can exit the sketch, and that can be extruded into a solid. So the spline enables you to make these very free-form organic shapes. Now, as is often the case in CAD, if you then, if I just go back in and just put a dimension on that bottom line. If once you've drawn your shape, you decide that you want to change that dimension, there's no predicting quite how the rest of your shape is going to adjust when you've changed one aspect if all of these other points aren't fixed. So our endpoints are attached to this line, so they've obviously moved apart to match the change in the dimension. The rest of the spline, there's nothing fixing any of these. And so you can end up with a lot of points which you need to drag to adjust to kind of reshape. So I've drawn a lot more spline points there than we had in our original model. I'm going to delete that and redraw a more sensible spline. So we had a shape that was more sort of had a slight indent for finger to go into, and then came down to a point like that. I'm just going to get rid of the dimension. Join that up. So what we want to do is constrain our spline. First of all, we want to essentially make the adjustments to get the shape a little bit more how we actually want the final part to look. And that's the nice thing about splines, is they're very adjustable. I'm going to make that line horizontal to lock that. And it's not happy because that line isn't horizontal. I just realized that I've managed to rotate my axis. That's actually horizontal. And to try and kind of rotate and move this whole shape now becomes quite cumbersome and painful.
That's interesting that you can't just select all of them and rotate it.
Yeah, I don't know if that is possible. It would be really handy if it was. I've definitely found with splines, you save a lot of work if you get them kind of roughly right first time.
Have you tried like using like Illustrator to import the lines and shapes and then extrude from there? Is that?
I haven't. I don't know what actually there's a whole area of SolidWorks I've not played with. So it may well be that there are ways to import SVG or other
I'm just
other kind of vector drawings,
Yeah.
and there are quite kind of nice. I use Inkscape, the kind of free vector graphics program, and that has really nice spline curves with adjustable curvature points. These ones are the types of splines where you just kind of click and it auto smooths everything between them.
Sure.
Let me just put the dimension back on there. About 55. So if you want to completely define your shape, then what you actually need to do now is dimension all of these points. I won't do them all because it'll just take a while, but and they need to be dimensioned in both directions to fix them. You'll see that when they're fully defined, they'll go like other shapes. They'll go from blue to black. Just zoom in on that one. So that one's now a black cross at that point because it's fixed with respect to the origin. This one's still blue. I've fixed it horizontally with respect to some points. But you get the idea. You need to kind of put dimensions to both its horizontal and vertical position in order to fix it. And then once they're all fixed, then the shape will behave more predictably when you adjust. Now, if you want to actually make things kind of scalable, then you need to actually start using equations and say that if this length, we define this length as a variable, and then we could say that this piece should be maybe a third of the way along this length. And so we define the dimension from here to here. Right. We define the dimension from there to there relative to the value that we'd use for this dimension. That's something that we went through, did quite a bit of work on in previous session about using equations. So I'm not going to repeat that just now, but we'll look at equations towards the end of this session on another part. Let's assume that we've made this part fixed enough. We're happy with its shape, and I'm going to make it a little bit thinner. I don't want it to be quite that thick. So the sensible way, I think, to design this part now would be to go and save that as our kind of overall shape. I'll do a save as. I'm going to call it template shape. Now what I can do is go into a new part and derive it from this part. So I can start a new part. And the first thing I'm going to do is insert my other part, my template shape. And it's asking me to mate it, so I will just fix that corner to the origin, so it's happy that it's defined in space. So I've now got a part derived from my other part, which means that that first part that I designed will dictate the shape of this part. And now I can start putting on the other features which are going to enable me to locate. So for our razor blade, we had a cut in this face, and it was, I'll keep it simple and pretend it was just a rectangle. We'll define some dimensions to fix it in place. And it's looking for an angle because I've constrained its size and position of that corner, but I haven't constrained the angle of tilt that we've got it at. So let's put it at 150 degrees. Now it's fully defined. So when it's fully defined, everything turns black and it says fully defined down the bottom. Exit that sketch and make it go 2 millimeters in, just so it's more visually obvious what we're doing. And now all of the other parts which came on here were to enable us to locate the razor blade, and I had corresponding parts on my other half. I'm just going to go back in and adjust some of these to go in and edit the sketch properly. So I've just moved that point up and I'm going to increase that angle. So now I've put this angle on and everything's constrained, I should be able to rotate this. Because I've defined that these lines are all perpendicular to each other. So it's a rigid rectangle. And so this angle is the only thing controlling what angle it's at. So that's a way you can do a rotation after you've sketched something. Without the constraints, that wouldn't be possible. I want to make it a little bit thinner. There we go. That's just to give me a bit more space to put in the other parts. So the other things I had were some protrusions that would hold the razor blade in place, which I would do through an extruded base. But because I want to actually have equivalent, if we go back and look at my original part, just shrink my windows down a bit. I've had these open on a bigger monitor. Oh, I've rolled back a dependent part. Look at that one instead. So you can see these two parts, where this one's got things that protrude out, this one's got things that protrude in. So the two plug together. That one's also got some features rolled back. So I've got these holes and I've got these pegs. Now I want all of these to align between the two parts. And because I was just designing this on the fly, I did probably what most people would do, which is I defined them by putting dimensions on. So on this part, I said they're 24 apart. And when I was designing this one, I said they're 24 apart as well. But there's no link. So if I went in made those 24 and a half, this part, they're still 24 apart. And so now my two halves don't line up, which is not ideal because you've got to keep all of these dimensions in sync between multiple parts. So a better way would be to add these onto our derived part as well. So if we go back to our original template shape, what I'm going to do is I'm going to put a sketch into it. And I'm going to create everything as construction lines. So they're not going to actually be used for making features, but they're going to be used as a reference for attaching things. So I can make them for construction before drawing them. Let's have a line there. Another line there. If I wanted things to all be exactly the same diameter, I could also do the same thing with some circles. Now I need to put some constraints on these so they're all fixed. So I want those to be perpendicular. Those to be perpendicular. I want to make sure that my circle is where those join. Oh, that wasn't what I intended to happen. Incident, there we go. So you can see as I start defining things, they they turn black as they're fully defined. Okay, so everything's fully defined there. I can exit that, save that. So I've got this construction geometry in my part. So when I go back to our, oh, not that one. Too many windows open. There we go. This part should now contain our sketch geometry, although I'm not seeing it. I need to. That's interesting. I wonder if I had to actually use construction geometry instead of a sketch. Let me go back to close some of those. I'll just check it wasn't that it hadn't rebuilt. No. What I'm going to do is put a couple of points in attached to see if that works. Intersection. There we go. Okay, that is also not coming through. So working by trial and error, what I'm going to do instead is actually make a physical feature. Using that. And use that sketch to make an extruded cut. I need to put my I need to edit the sketch first to make that non-construction. And I'm going to shrink these down slightly. So they're not really big holes. So I'm going to make that one 2 mil. That one 1 mil in diameter. Now I can make an extruded cut from them. Go through all. Save the part. All right, now the features from my template have appeared on my main part. I can now actually derive some of this information from those features. So my rectangular cutout, I'm going to create a construction line that joins these two. Now I've got that line, I can get rid of this angle definition. Because instead I can say I want my shape to be parallel to that construction line. And then I'm going to make the midpoint of that. I can't make it vertical because it's not vertical, it's sloped at an angle. But because my shape is 16, if I make that distance instead from that midpoint to there, so make it a driving dimension. Oh, what have I done? Let me just take these dimensions off for a second. Right, if I say that that distance, I know why it is, it's because it's made that vertical, and I don't want that vertical. Subtle difference between the vertical and the direct point-to-point dimension. Now to make that 8, that has to force that. It doesn't have to force it unless I do the same with this one. Make both of them 8. It should only be able to solve by snapping that to exactly the midpoint around there. And now that's fully defined again. So its width and height fully defined around that. Can exit sketch. And now, because in one of these I want these to be holes and in the other I want them to be studs, what I'm going to do is I'm going to do a boss extrude. And I'll do it from the back plane. And I'll make it centered on that feature. And I'll do one on that one as well. Let's make that one 3 millimeters. That one 4 millimeters in diameter. Now they're fully defined because they're locked to the centers of those two holes. So I don't need any other dimensions. And then I want to flip the direction that they extrude so they come through this way. And I want to make them 5 millimeters tall. So now those holes have disappeared. I've got a smooth black plane again, but I've actually got two studs which are located based on the positions of those holes. So I can now save that. Save holder part 1. And now, to save me having to repeat a lot of those operations, what I'm going to do is do a save as again and save a part 2. And now I'm going to delete that boss extrude, but I'm going to keep the sketch it was based on. So I'm not going to delete absorbed features. And you'll see the sketch has dropped out. And now I'm going to create a cut extrude from that sketch. So go through all. Now I've got two holes which perfectly match up with the pegs that are on my other part. And the reality is that I want them to be slightly bigger, so I can now come into the sketch and make them 4.4, 3.4. So there's a little bit of room for the fact that I get a bit of expansion on my 3D print. So I've got part 1 and part 2 of my holder. Reopen part 1 because it would have closed when I. Okay, and they will perfectly join up and join together, apart from one thing. I need the mirror image of one of them. So what I can do is select a plane on my part, and I'll select the rear plane. It doesn't really matter which plane I choose. And to remember where it lives. This is one of those operations that I do once in a blue moon. Oh, it's in insert, that's why. Mirror part. So although it's on the insert menu, I'm not inserting something. What I'm actually doing is inserting into a new, see, it's gone to part 3. And now I've got a part which is the mirror of that original part. So I can save that, and I'll call it 2. So I've now got my mirror image of this part. So you can imagine that those two, if I built an assembly, would go together and those holes would perfectly line up. So I've got to kind of the sort of end point of what I was trying to show, but the real magic is in the fact that it all comes from that derivative from that template. So if I go back to my template shape and decide that actually, I don't know, this angle wasn't quite right, I'd rather that that was actually at 170 degrees for a steeper, sorry, a more shallow slope. And I want to move that up. So maybe I will flip that dimension. That wasn't what I intended to happen. That's what I wanted to flip. So I've moved that so 3 millimeters up and at a shallower slope. And let's go into our spline, and these ones that I've not constrained yet will be easier to adjust. So let's kind of change our overall shape to have a kind of much bigger bulge at that end. So I've made some adjustments to my template shape, and we should see that those have been applied automatically to our part 1 and part 2. So they've now got the bigger bulge, the shallow angle. Everything still lines up because everything is derived from that template. And when you're iterating on a design, that saves you an immense amount of work, because the initial setup was a bit complex, but now when we print this and we discover that this groove isn't quite right, we can go and make an adjustment to that groove, and it will apply to all of the parts, because they're all kind of have got that chain of derivation. Now, I couldn't build up from a template part in the same way when I created my save those so I can close them. When I created my actual razor blade holder, because I had actually already designed it before I worked out what curve I wanted here. If you remember, if I roll it back, in fact, that's the part 2. We find the part 1. There we go. I've done all of the design of this part to get the actual fixing of the razor blade before I designed the curved shape. So instead, I used a different technique where you've got a shape, and what you can do is you can go and insert another part. So I'll do it with, I'm just going to save a copy of this so I don't destroy my original work. So I can go insert part, and what I'm going to insert is my template shape. You can see that initially it's just free floating, but if I select locate part with move copy, then now I can create some mates. So what I want to do is say that this bottom face is aligned and this rear face. Oh, I've closed these two faces are coincident, and so at that point and at that point, I want to be five millimeters separated. quite understand why that won't let me flip that dimension. Let me. Delete that distance. If in doubt, try things a different way. Let's go and edit this one, that one. Okay, my shape's slightly longer, so that's why I can't quite fit that in. Instead, let's just go and make the original slightly longer. There we go, so it fits entirely inside. So I've essentially inserted that second part into my project. So this is what we designed. And then I've said, insert that. What I can do now is I can go into Tools. Is it under Tools or is it under Insert again? There it is, staring me in the face, combine. So what I'm doing is combining two bodies. So if I open up my feature tree and find the solid bodies, I've got my original and I've got my template shape. And what I can do is decide how I want to combine them. And in this case, I'm going to say that I want where they have common overlap. So tick that. Can you see that all of the part of my original part, which doesn't overlap with that shape, has disappeared? So what I've been able to do is take an existing part that I've designed and change its profile by inserting a common shape to inserting a second shape to make a kind of operation. You can also do an add or subtract. So if I do a subtract, then what it does is it cuts the one part away from the other, as you can see. Oh, the dialogue opened on the other screen. And then I can decide, do I want to subtract from all bodies or just selected bodies? I'll just say all bodies. You can see what's happened is it's actually removed one shape from the other. So that shape combination is another powerful way that you can build up these derived shapes. I somehow lost the selection. There we go. And just to prove that that has done what we've said, if I go back to my template shape, and we make some obvious changes to the shape. You can see the little rebuild icon, traffic light icon has appeared, which means it's not actually applied that change until I hit rebuild. You can see. So that template shape again is defining the shape of this part and any other parts that I do the same operation with. And just to show you how powerful this technique can be, I was working on a project to build a robot cat, and I designed this body shape for the cat, and I wanted to make it modular. So where my servo brackets were, for example, to make this thing easier to 3D print and to 3D print the complex parts separately, because I wanted the smooth curved surface to be facing up on the print bed. But I didn't want to have to build a load of supports around this complex geometry. I wanted to print the bracket that was this part of the body as a separate modular part. But I wanted all of these curves to perfectly line up. And so I've used this technique, and I've done it again with the cradle that would hold the electronics. You can see the part that's now colored blue. When it's not highlighted in color, it perfectly lines up contour-wise with the others. And of course, I've done that by using the same techniques. So if I open up that cradle, you can see that it's actually derived from a core block. That core block was the shape that the overall cat body was going to have. What I did in this case was I topped and tailed it with some cuts, trimmed the width, and then built up all of this complex detail, but the actual exterior shape of it perfectly matches the overall cat body. Likewise, this part. Now this part is taking this technique a step further, because I've got a lot of servos in this robot cat. In fact, if we open up the complete cat model, this is still a work in progress, so I haven't finished this project. It's just going to complain that none of the fixings are available in this version of Solidworks. So all of the mates of the fixings are broken, but that's not relevant for here. So there's a lot of servos, and they all have a common kind of core fixing shape. So if I open up one of these, all of my servo holders have this common cutout, which is to tightly fit a particular brand of servo that I've picked. And they also all have this particular configuration to hold the servo horn of the adjacent servo that will make up this joint. And this has come from a mirrored part. So let me open, and it's not going to fit the wrong shoulder. Let me go back. Close some of these. Let's try one that isn't derived from a mirror. Of course, that one is as well, because I've, okay. Let me go and open the originals directly. Try that one. No. See if I get lucky with this one. There we go. So it's a different part, but it's got the same principle. It's got this core block that, if you look in my, I'll just roll back right to the start. This is my core servo block. So all of my servos are held in this particular shape. So I created this as a separate part. I then adjust the size of it. In this case, it's just very, very subtle, but it's making the base slightly thicker. And then I'm trimming a little bit off the end. And now I'm inserting another part. So this is my other base part. All of my servos that attach via their servo horn fit into this shape. So I brought one of those in and put it relative to where I want. And then I just make a whole bunch of adjustments to kind of build the part out and then do all the filleting and trimming. So we end up with a neat part, but if I need to change the shape that holds the servo, or the width of these forks, or the position of these screw holes, or diameter, anything to do with those common parts, then they will propagate through the entire CAD model. And you can see there's a lot of parts which have those common features. They're all different shapes, but they all have those forks. There's more in the cat head, has one in. The actual body has those forks. You can see where the tail servo is. So these modular parts that we were looking at that are part of the cat body. I'll open one of these up. You can see this one at some point, if I roll it back, was derived from my common servo fork. And then I built it up until I had the dimensions I needed to fit into my cat body. And then you can see that I bring in the cat body in position, and then I do my combine. And what I've done is I've subtracted the cat body. So the difference between before and after is just see the subtle curve that gets chopped off. So it's not doing a lot, but the curve of the cat body is trimming the back of this bracket. And then I build up the rest of the shape. So I've got something that I could nicely 3D print in, probably in this orientation, without needing to use supports. And then it inserts seamlessly into the cat body. That one. So you can see it when it's colored blue. But when they're all bolted together, it'll look like one seamless part. So it's a very powerful technique that the more I've kind of got used to the complexities of it, the more it's paid off. Because if I want to make any change to the shape of this overall cat body, then it will propagate to all of these parts. So all of these curves will be perfectly aligned. When I started this, I was using manually drawn curves, and it was killing me. So so we've done a full hour there. I've shown you probably enough for one session. I will open the floor for questions, either about anything I've shown or anything else about SolidWorks you might want some help with.
A question about your cat robot model. How did you draw the head? Because it looks very realistic. Or how did you design, was it something that you got from somewhere else, or did you?
It was from somewhere else.
Oh,
I spent a disturbing weekend in CAD beheading a cat
oh,
because, let's see if I can find the cat's head. Okay, that's maybe not the file. Let's go back to the complete cat and open the part I'm actually using. So there's the cat head with my, I kept this simple and bolted the servo bracket in as a separate part. So it's just got two holes for bolting the bracket in. But if we roll it back, actually I've already derived it. So you can see that the first thing I've done is a scale operation to make it the right size. I originally started with a cat that I found on a website called Turbo Squid, and it was a complete whole cat. And the reason I was looking for a cat head, my original, the original robot cat design is actually called Open Cat, and if you search online, you'll find Open Cat as a fully 3D printable robot cat, but it's very kind of skeletal looking. It's robotic rather than lifelike. And so what I did was I took the basic idea from it and started trying to build a much more shapely looking robot cat. And the head they had was very low poly, so very few triangles, and it just kind of, it looked much less lifelike. And I came across a website called Turbo Squid, which is a 3D model sharing website. And on there, someone had published royalty-free with a license to kind of use for derivative works, a complete cat model. And I imported it. It was a triangular mesh file. So I imported that and had to do quite a lot of processing on it. But I kind of cut its head off with a plane. And then because the file was absolutely massive, what I did was I think I saved it out as a poly file and then re-imported it. So you can see I've got imported at the start, so that I was able to throw away all of the data for the rest of the cat's body, because that was really weighing down my CAD model and I didn't need it.
it's really good.
And I also chopped its whiskers off because the original had really fine whiskers, but it also did 3D print, of course. And it had some quite disturbing teeth as well, which I've removed. So you can't see them now, but yeah. And it still needs more work because it looks really good here, but when I 3D printed it, it looked like a kind of alley cat that had been in a fight, because some of these points on the ears, can you see they go to almost zero thickness? And so with the 3D print, what happened was you kind of ended up with kind of little notches out of the ears where those bits didn't print right. And it looked like it had been in a scrap with another cat and had its ear chewed.
Oh dear.
But yeah, it's a project that has been parked in a box for the best part of a year. But I will get back to it at some point and finish actually printing it. There's a lot more parts I wanted to design. I've kind of done some of the parts. I'll go back to the model. So some of the parts look more lifelike. The legs are still very much how they were originally, except I designed these more realistic cat's paws because the original just had spheres. So I designed something that looked a little bit more paw-like, but I don't like how they go kind of like thin legs to kind of really wide. So I want to try and build some more shape into the legs. I've done it on the shoulders. You can see how the shoulder kind of servos kind of, they've got more kind of muscular lifelike shape, but the rest of the legs are still quite kind of robotic, and there's plenty more work to do before it's a finished project.
I guess the easy part will be when you program it to ignore everything you say.
Yeah. So the programming part is going to be a massive project in its own right, I'm sure. What I'd actually like to do with it is find some way of actually getting feedback from the servo positions so that I can pose it and have that feed its position back into the software, so that I can kind of do some kind of empirical kinematics, if you like, sort of take it through some kind of moves by manually positioning it, and have the have those kind of be recorded for playing back, so that I don't have to try and completely write the kind of movement routines kind of programmatically to try and make it lifelike.
So are you planning to use tail for stability, for example, as well, like in a real CAD?
So there will be a tail. Whether it will be there for balance or just for kind of looking nice is one of the many unanswered questions of the project.
Hmm.
It was a project which really pushed my CAD learning, and it will really push my kind of robotics programming when I get to that phase as well. But I learned enough CAD from it that it inspired me to work on some much simpler projects, which have been enabling me to actually finish something. And I'll come back to this as I increase my skills and have more time for it. So projects like the razor blade holder that we started the session with are kind of nice because you can do them in a few hours, but you still learn a lot of CAD. And then you can come back to a project. One of the reasons I stopped working on the cat is that I got so bogged down in getting these curves working and getting everything aligned. And I was just kind of like tired of endlessly fiddling with it and having to readjust things and then reprint parts. And so I put it aside, and I haven't gone back to it yet. Good question. Anything else anyone would like to ask before we wrap the session up?
I had a kind of, it's not exactly, and thanks for showing this. I didn't know about the templating. That's really cool technique. But I did have a question because I'm just starting out. Like, and this was more about like trying to cut out something in a model in layers, so you could say laser cut cardboard or wood to build it.
Yeah.
You know, like they did in the Yoda thing. Is SolidWorks the thing to look into, or is there another program that would do that?
For making slices like that, I don't know what
I can ask.
I don't know what software people use. It sounds to me like it would be a project where however you make the model, you would want to do some sort of scripting to generate the slice profiles. So in effect, if you kind of imagine this cat, let's go to the cat head because that's more of a sort of shape. If you wanted to create slices of this, what you'd probably want to do is get the top-down view, and we can do it kind of visually with the section tool. If I section on the top plane, I have to actually rotate it to grab the grab handle. But each of these contours that you see is in effect the. So what you would want is some kind of script that would go through and take the contour, generate each slice.
Of a
So
particular
it might be possible to do it in a CAD program, but it might not be the easiest way to achieve it.
Okay.
What I have done with CAD and laser cutting is built things up. If I come out of that. This was the project that got me started in CAD. And it's just going to complain because there's lots of fixings which aren't present in this version of Solidworks. Just have to click through a few errors. This project's never been open on this computer before, so it's finding lots of components which is asking me where they are that aren't located in the right places. We'll get enough of it loaded to. Okay, so this was a robot that I designed, and it's all made out of laser cut acrylic. So I designed all of the individual parts in SolidWorks. So you can see they're all 3mm thick material, but I designed each part kind of by hand to assemble up into the kind of final robot. In fact, you can see it on the shelf behind me in my video.
Cool.
So that's an example of kind of and the way that I did the laser cutting is I generated drawings. So I open up one of the drawings.
Oh,
Yeah. So take the various parts.
then extrude them to the exact same level.
Yeah. So
Oh, yeah.
there we go. There's our razor blade holder that we drew tonight. So I'll take the front view, bring it into the drawing, and then save the drawing as a DXF file.
Yeah, right.
And then I could take that DXF file into Inkscape, make any other further adjustments that I wanted in terms of layout. So I tended to not try to do the layout in SolidWorks, but take the parts into Inkscape and then do the final layout for laser cutting there. And then I would export the DXF from Inkscape, and that's what the laser cutter at the makespace would take as its input file.
Cool. Cool. That makes sense. And one last, how do I sign up to get in? To get one of the SolidWorks things?
So there's a link on the meetup.
Oh, there is. Okay.
To the form.
Yeah. I'll do that.
There we go.
Okay.
So you fill in that form, it adds you to a spreadsheet. I then just get your membership validated with the Makespace administrators. And as soon as I've got that done, I send an email with the details to you.
Okay.
Okay. Any other final questions before we wrap up the session? If not, then I hope you found this useful. I'm open to suggestions for future sessions. So if there are any particular topics or problems that you're finding challenging that you want help with, then I'll be happy to do sessions on topics submitted. So feel free to kind of comment through the meetup system to kind of let me know. Otherwise, I will think up something based on what I've been doing in the weeks leading up to the next session, and I will see you all in a month's time. And we might even, if restrictions continue to be lifted, be able to do some in-person sessions in the Makespace classroom at some point. But I have to wait for the classroom to be allowed for face-to-face meetings before we can do that. Okay.
Thanks
you
so
all.
much. That was great.
The session will appear on YouTube in due course. You'll find links to the other sessions in the meetups and on the CAD Club website. So thank you.
Thank you.
And good night.
Thank you.
Good night.
Thank you.